Okay, I'm going to try to come up with a good way to do a project-based matrix for the NIMS part. Okay, so we're going to start out up here in the corner with NIMS, bench work, part, okay. And then we're going to come off of that and we're going to have some categories. So we've got something coming off of here, which we're going to say is the blueprint or working drawing. Okay. And then off of that, we're going to come up with another branch. Okay, and it's going to say rough cut measurement. Rough cut and measure, we'll go with that. And then we're going to come off of that one with going to go to the saw, okay. Rough saw cut. That's where we leave an 1/8 inch. Over size, okay. This is all planning, okay. This is why it's important so you don't end up scrapping out your part, right? So after we do the rough sawing, okay, we're going to come back and we're going to have to go to the milling machine. Milling machine. Now I'm going to give you this one. It's going to be a 1/2 inch cutter. Okay, so the RPMs of a 1/2 inch cutter is going to be 4 times 100 because we're going to use cold roll, which is 400 divided by 0.5. Okay, here's some real quick math. This is all you have to do. Double this number. 800 RPMs. Now that's pretty simple for that one, okay? When we get to the drill press, probably not going to be that easy. Okay, so then you're going to mill the ends, okay, down to size. Now, all this is now completed. Now we get to go back up here. Give us a pretty big box. And we're going to lay out, can you see me? Lay out holes. X and Y axis, okay? And lay out holes on X and Y. There's 3 holes. And they all equate out to like 3/8. Or they have something to do with 3/8. So hole 1 is just a 3/8 hole, okay? Hole 2 is a 3/8 16 United National Course tapped thread or tapped hole, and then 3 is what's called a 3/8 through hole. Okay, so each one of those has to have RPMs for the drill bits, okay? So now we're going to do that when we get over here to the drill press, okay? Give it a pretty good sized box, and we're going to the drill press, okay? And we have to center drill center drill, and that's always 200 RPMs. I'm going to give you that one. Now hole 1, okay, let's say that's H1, is going to be 4 times 100, which is 400, remember that. 400 divided by 0.375 equals, written down here, 1066. 1066. Okay. Hole 2, 4 times 100 equals 400. 400 divided by, now this one's smaller because it's a tap drill size, right? And it's going to be 1280. You take 400 divided by 0.312, that is 1280 RPMs. All right, hole 3, a little bit bigger, right? 4 times 100 equals 400. Come over here, we're going to take this one by 403, which is 1330 seconds, okay? And then this one's going to equate out to 985. Okay, and all these are RPMs. Bring my little thing here. RPMs. That's how fast stuff's turning, okay, while it's cutting. So, let's go back over here, recap a little bit. NIMS benchwork part. Blueprint or working drawing, that's what you've already done, right? We'll come back here and we've got a rough cut saw and measure. So we're going to rough cut and measure, sorry. Come over here to the saw, which is a rough cut. That means you're going to make it an 1/8 inch bigger, okay? So if it's 3 inches now, you're going to add an 1/8 inch and just do it like this. 3 1/8, okay? That is the rough cut, 3 1/8. The 2 inch part will already be determined. Then, after that, we're going to go to the milling machine and we're going to use a 1/2 inch cutter and we're going to mill the sides of our block down to 3 inches, okay? And we're going to turn that, 4 times 100 equals 400 divided by 0.5, which is 1/2 inch. You just double that number and that gives you 800 RPMs. Pretty easy, right? Now, after that's all brought down to size, we're going to come back over here and we're going to lay out the holes in X and Y. You've got 3 holes. You've got a 3/8 hole, a 3/8 tapped hole, and a 3/8 through hole. And that means the bolt will slide through the hole without getting caught. Okay? After we do that, we're going to come over here to the drill press. We're going to use a center drill. Now some of you guys have used them and it looks like this. Okay? Nothing special about the center drill, except for the fact we always run them 200 RPMs because they will break. Now, hole 1, 400, that's 4 times 100, that's cutting speed, equals 400, divided by 3/8, which is 0.375, equals 1066. Same thing down here, hole 2. 4 times 100, 400 divided by 5/16, are also known as 0.312. You get 1280. Okay, zoom in on that a little bit. You get 1280. Sit still, camera. All right. Hole 3. 4 times 100 equals 400 divided by 0.403 equals 985 RPMs. RPMs. What's that mean? Revolutions per minute. That's how many times that thing turns around in a minute. Very important, okay, for tool life and chip removal. Now, After all that is done, we have to stay at the drill press. Come over here. And we're going to use a countersink. Countersink. And it looks like this. Scoot down a little bit. Goes like this. Goes like this. Comes up here. It's got this little decorative view here. Okay. This is going to be, I believe, by print at 82 degrees. And that's from 90, 82 degrees. Okay. Countersink. We run that at 200 RPMs. What's RPMs? Revolutions per minute. Now, on this particular print, there's not sizes, I don't remember, that you have to hit, okay? Sometimes it asks for a diameter. Okay, so if you have a hole, and then you see something that looks like this, right? And this is the countersunk hole. Let's draw a little box here. Okay, this measurement right here, this diameter, could make a difference. And that would be where this thing would rest in that part. And that would deburr, okay? So deburr the edges. Now, why in the world is this man going to this much trouble to get us to understand this? Because when you go to start a project, even if it's a CNC project, actually that's where some of this comes from. You have to know this information to be able to program the machine. Okay, so it's a big deal. So we're going to start at the beginning and try to step this out. Now, what's your project? What I want you to do is I want you to mimic my chart. Now, feel free to make a better one, okay? No big deal to me. Make it look good, okay? Have to have this information. Now, along with this chart, I need a slideshow or a PowerPoint. I'm going to write it on the back here so you can say I said it. Slideshow of each step. So you're going to show me, how can I say this? You're going to go out to the internet and bring in a picture of each tool. Okay? So you're going to go out and find me that. Feel free to add links, okay? Links, web pages of how to calculate RPMs. Okay, so calculate RPMs. Okay, I'll give you a hint. Go to the Haas website. Very good resource. Okay, so you're going to make a picture of each tool in the slide that goes along with that. So I'm going to give you an example. Picture of each tool. So let's go back here. Okay, so if I'm going to use an end mill, where's it at? End mill. Here, this one, right here, right? So my picture from the internet is going to be, oh gosh, I'm not very good at this one. An end mill, okay, from the internet. It's kind of late, it's been a long day. Anyways, your end mill from the internet, right? You're going to put that picture on that slide. On the slide. You're going to tell me all about the RPMs, okay? Real important, that's what I want to know. How are you going to do it? Give me pictures, give me words, give me web links. This is what I ask of you. Please do. Okay. All right, I think I beat you to death on this one. The next step for this, after this orders of operation is done, if we get to go back to school, we will be starting on this part. It's a little scary for me because you guys haven't seen a machine since March. Okay, so I'm sure we'll have a little safety day or two. But folks, we're getting down the nitty gritty and we're going to have to hit the ground running, so you got to be ready, okay? So this is going to be your assignment. And I will catch you later.